Welcome to this video on the power rule of exponents applied to both negative and positive exponents. Before I can even tell you about the power rule and introduce you to it, I need to remind you about the difference between something that looks like this, negative 4 to the second power, versus something like this, which is read negative 4 quantity to the second power, because the negative 4 is enclosed in parentheses. So, if I have something that looks like negative 4 squared, okay, what is the base? In other words, what is getting squared? Is it the 4 or is it the negative 4? Well, the answer is just the 4. In fact, if I wanted to, I could rewrite this as negative 1 times 4 squared. That's what we mean. So I could rewrite this as negative 4 times 4. Again, the negative sign is not getting duplicated, it is not getting squared, so when you write it as multiplication, you should only write one negative sign. So negative 4 times 4 is negative 16, and that's our final answer. So let's look at the other side of our page. So we have negative 4 quantity squared, right? So what is the base here? In other words, what is getting squared? Well, the parentheses are an invitation, meaning everything inside of the parentheses is getting squared. So our base is no longer positive 4, our base is negative 4. If I rewrite this as a multiplication problem, it's going to be negative 4 times negative 4, which is going to give us positive 16. Notice that we have the same number but opposite signs, so different answers based on whether there are or are not parentheses. So as we do these problems and apply these exponent rules, we are always going to need parentheses. So just keep that in mind as you go through this. All right, let's do a few examples. So now we have negative 2 to the third power. Again, this negative sign is not being raised to the third power. The base is just 2. If I rewrite it as multiplication, I only write one negative sign, and I write 2 3 times. So that's going to give me negative 8. On the other side, we have negative 2 quantity squared. The base is no longer 2, but negative 2. So what's getting raised to the third power is negative 2. So we have negative 2 times negative 2, which is positive 4. Positive 4 times negative 2 is negative 8. Notice in this example, because we have an odd exponent, we have the same result. However, be careful, because when I'm grading, I still want to see these parentheses when you rewrite things using exponents. So you still need to be over here writing things with parentheses. Okay, last but not least, we have negative 2 to the fourth power. Again, the base is 2. The negative sign only gets written once, and the 2 gets written 4 times, so we get negative 16. Over here, we have negative 2 quantity to the fourth power. So the base is negative 2, so we multiply negative 2 by itself 4 times, and we get positive 16. So again, notice we have different numbers. So the parentheses don't seem to matter, as you can tell, when we have an odd exponent. But again, you still need to write them because that's how you translate some of these problems. When we get into individual examples, hopefully you will see what I'm talking about. All right, so without further ado, let's introduce our power rule. So the power rule of exponents says a to the m power raised to the n power is equal to a to the m times n, or a to the mn. Okay, that's what the power rule says. So let's demonstrate this for ourselves. So if we have x to the third power raised to the second power, well, anything squared, isn't that just the thing times itself? Right? It's just that. And so if I have x cubed quantity squared, that's the same as x cubed times x cubed. Well, here I could either write, I could apply the product rule. Remember, the product rule tells me to add my exponents. That will give me x to the sixth. I could also go another route, right? I could also think about just rewriting it as multiplication. So we have x times x times x times x times x times x. And again, that still gives me x to the sixth. Notice I could have achieved the same result by simply multiplying the exponents 3 times 2. So this is a demonstration of the power rule of exponents. So sometimes things are going to look a little bit different. So for example, what if I have a times b all raised to the m power? Well, what I'm going to do is I'm going to raise a to the m power and also raise b to the m power. Okay? So this is another application of the power rule. Likewise, if I have a divided by b all raised to the m power, that's going to be the same as a to the m power divided by b to the m power. Okay. Please, however, be careful if we have a times b to the m power. That is not the same as a to the m plus b to the m power. And we'll talk about this more as we go on into the next sections. Alright, so let's do some practice examples. Again, this is a good opportunity to pause the video, see if you get it right, unpause it, and check your work. Okay, so a to the fifth then raised to the third power. So remember, we are applying the power rule because we have a power raised to another power. The power rule tells us to multiply exponents. So 5 times 3 is 15, so we have a to the 15th power. Okay, now we have a, b quantity squared. So that's going to give me a squared times b squared. Now we have 4a to the fifth power. So this is going to be 4 to the fifth power, a to the fifth power. Now remember, we actually have to evaluate our numbers. Well, 4 to the fifth power is 1024. So we have 1024a to the fifth power. All right, now we're getting into a problem, an example where this is something you might actually see on a homework or a quiz. So we have x squared y to the negative 7th quantity raised to the 4th power. So we're going to have x squared raised to the 4th power, and then we have y to the negative 7th raised to the 4th power. So again, we're applying our power rule. Our power rule tells us to multiply our exponents. 2 times 4 is 8. 7 times negative 4 is, negative 7 times 4 is negative 28. However, we've done all that work, but remember, our directions are always going to tell us to express our answer using only what? Only positive exponents. So we have to do one more step, and we have to rewrite this using only positive exponents. So as you can see, I'm a little bit out of room, so let me see if I can write this a little bit smaller. So we have x to the 8th, y to the negative 28th. Okay, so the thing that has a negative exponent is the y. So to make it happy, right, to make our tenant happy, we're going to move it into the denominator. So we have x to the 8th divided by y to the 28th power. And that's going to be our final answer. Okay, so now we have 2u to the negative third v squared quantity squared. So everything is going to get raised to the second power. So we have 2 squared u to the negative third quantity squared v squared quantity squared. So that's going to give us 4, and then we have u to the negative third squared. Remember, the power rule tells us to multiply our exponents. So that gives us negative 6, and then 2 times 2 is 4. Again, we would be done, except for, remember, our directions are always asking us to write the expression using only positive exponents. So this u guy is the one who has to move down to the basement apartment to make him happy. Okay, so we're going to get 4v as in Victor to the 4th power divided by u to the 6th. Okay, let's keep going. So now we're going to have x squared, y squared, squared. So that's going to give us x squared, and then remember we multiply these two exponents, which gives us 4. So we have x to the 2nd power, y to the 4th power. Okay, next one. We have 2 to the negative 3rd power times a to the 4th, also raised to the negative 3rd power. So I'm going to leave 2 alone for a second. I'm just going to leave it as 2 to the negative 3rd. Okay, and then I'm going to rewrite this. Remember, we have to use the power rule. The power rule tells us to multiply exponents, so we have a to the negative 12th power. Okay, so here's my secret. A lot of people just panic when they say 2 to the negative 3rd, or another thing they'll try to do is just type it in their calculator. And the problem, if you type it in your calculator, is that it's probably going to give you a decimal. It's probably going to give you 0.125, and we do not want decimals. We want fractions. Okay, so just hang with me here for 1 second. Just believe me. Okay, what we're going to do next, instead of evaluating the number, is we are going to change all of our exponents into positive exponents. So remember, to make our tenants happy, when they're unhappy, we have to move them, in this case, downstairs. So I have 1 over 2 to the negative 3rd, I'm sorry, not 2 to the negative 3rd, 2 to the 3rd power, a to the 12th power. Okay, now, right, I can evaluate 2 to the 3rd power. Well, that's just 8, right? So now I'm going to have 1 over 8a to the 12th power. Okay, and that's my final answer. So you might remember I said you're going to get 0.125, right? Well, that is 1/8, which as you can see is what we have right here. But again, we want the 1/8. We do not want a decimal answer. So if you just pause on trying to evaluate it and change your exponent to be positive first, then you can get your fraction that you need. All right. Let's do this last example on this page. So this is going to be 2 to the negative 4th, x to the negative 4th, y to the negative 4th. Okay? Again, follow my advice. My advice is don't try to type 2 to the negative 4th into your calculator. Okay? Don't do it. It's going to give you a decimal. You're not going to like it because it's not going to get points, right? You have to have a fraction. Instead, what I'm going to do, right, is I'm going to take all these unhappy guys and I'm going to move them into the denominator. So now I don't have 2 to the negative 4th anymore, right? What do I have? I have 2 to the 4th power. Well, gee golly, that's easy. 2 to the 4th power, that's just 16. So I have 16x to the 4th, y to the 4th in my denominator. My final answer is 1 over 16x to the 4th, y to the 4th. All right, let's do a few more examples. Now we have a divided by x quantity to the 3rd power. Okay, that's going to become a to the 3rd power divided by x to the 3rd power. Okay, and that's our final answer. So let's keep going. Now we have a to the 5th divided by x to the negative 3rd quantity to the negative 4th power. So we have, what are we going to do here? Well, we have to apply the power rule, right? So you can do this probably in fewer steps than I'm going to, but I don't want to lose anybody, so I'm going to take a minute and write it out like this. Okay? So everything is getting raised to the 4th power, and then I can apply my power rule, right? So I have to multiply exponents. 5 times negative 4 is negative 20. Negative 3 times negative 4 is positive 12. Okay, so now I have to think about making my tenants happy. Who's unhappy? Well, my a, right, has a negative exponent. How can I make it a positive exponent? Well, I can make it a positive exponent by moving it into the denominator. And then I just need a 1 up there in the numerator just as a placeholder so that it makes sense when I look at it. So I have 1 over a to the 20th x to the 12th, and that's my final answer. All right, last but not least, we have a to the negative 3rd b over c to the negative 8th d to the 5th. And all of that is being raised to the negative 2nd power. Okay, so this is going to take a little bit of time. It might be a little bit time consuming, but all I'm doing is I'm just raising everything to the negative 2nd power. And in a minute, I will go through and apply the power rule. Okay, I think I did that right. All right, so we have a to the negative 3rd to the negative 2nd power. So we multiply those. Negative 3 times negative 2 is positive 6. Okay, here, this is really a 1, right? 1 times negative 2 is negative 2. Okay, negative 8 times negative 2, that's going to give me a positive 16. Okay, and then last but not least, 5 times negative 2 is going to give me negative 10. Notice when we first started, I didn't worry or bother about whether I had negative or positive exponents. So making all of my exponents positive, in general, the way I do things anyways, is always the last step that I do. Okay, so who is unhappy here? Well, b to the negative 2nd power has a negative exponent. We're going to move him down to the basement apartment to make him happy. Okay, a to the 6th power, he's happy where he is, so we'll leave him alone. Okay, c to the 16th, he's happy where he is. Then our d to the negative 10th power, he's unhappy, so we have to move him upstairs into the numerator to make him happy. So that's the last example for this video. So here is a display of all the different properties of exponents, and you should have a copy of this in your guided notes. So I want you to take a look at them, just look through them for a minute. Okay, if there's any of these properties that seem unfamiliar or confusing to you, I want you to circle them. Okay, and then if you're in a face-to-face class, ask questions. Next time we're in class, ask about those properties, ask to go over them. Okay?